Hi everybody, today we are going to work on part 2 of 1.6 objective, which was transformation of graphs. The first one is reflection about the x-axis, a reflection about the x-axis, and reflection about the axis. For example, I have an order pair which is original order pair xy. So if you're reflecting across the x-axis, all you have to do is change the sign of the y value. So x stays the same and you change the y value like that. So that's reflection about the x-axis. If I'm doing reflection across the y-axis, and that would be reflection, and I'm using different colors so I can graph them in these colors. About the y-axis, if you have original order pair xy, you are going to change the sign of the x. If it's positive, you change it to negative. So that's how we do reflections across x-axis and y-axis. So you can sometimes they also write the notation something different. If it's about the y-axis, they would say something like this. This is original. Hold on. I'm gonna do y equal f of x. Let me write it down under this so we know what we're doing. The original one, sometimes the notation look like this. It's y equal f of x. And when you change this about the reflection about the x-axis, you change the x sign, then it's going to change to something like this. But these two are exactly the same thing that I'm talking about. The same goes for the reflection about the x-axis, where the original is going to go y equal f of x. When you're changing this y sign, then you are going to do something like y equal negative f of x, which means I'm changing the y value to negative. That's sometimes the notation looks like this. So let me give you an example for reflections. I'm gonna graph the original y equal x squared. I'm just gonna pick something easy so you can understand. So I'm going to make a table of this. I'm going to pick some x values. For example, I pick 2, 1, 0, negative 1, 2. Plug in. When you plug in, that's my y value. You plug in 2 here, it's going to give me 4. Plug in 1 is 1, 0 is 0, negative 1 is positive 1 because negative times negative 1 is positive 1. And this is negative 2 times negative 2 is going to give me positive 4. So I'm going to graph that on this coordinate plane, and it's in this color. So 2, 4, 1, 2, 1, 2, 3, 4. Then I have 1, 1, 1, and 1. Then I have 0, 0. Then I have negative 1 and 1. Then I have negative 2 and 4. And I'm going to graph this, and it's look like a parabola to me. There you go. So that's how it looks. Now let's do the reflection about the x-axis, which is in pink color. So I'm going to use that pink color. Reflection about the x-axis, which was I'm going to do x, and I have y, and x values is gonna stay the same, and this is a reflection across x-axis. Okay, so x value stays the same, 1, 0, negative 1, negative 2, they stay the same. The y value, the one I have already, they're going to change the y values, the sign is going to change. So if it's positive 4, I do negative 4, negative 1, 0, and I am going to make this negative 1, and I'm going to make this negative 4. You see all the y values changed. Okay, so let's graph that and see if we get the reflection across x-axis, and you know that's x-axis, that's y-axis. So 2, negative 4, that's 2, 1, 2, 3, and 4. Positive 1 and -1, which is up here. 0, 0, stay there. -1 and -1, and I have -2 and -4. So look, this is a reflection across x-axis. You see that? This is, I'm reflecting like a mirror across x-axis. Now let's do reflection about the y-axis. And I'm doing y-axis up here. And since it comes out like the same, so I'm just going to do it here so you will see it looks the same up here. Reflection about the y-axis where we have x values and where we have y values. Now across y-axis we change the x values, the positive, negative, negative, positive. So this is going to turn negative. First let's write down all the y values. The one we have up here, the original one, it's going to go 4, 1, 0, 1, and 4. Change all the x values, like +2 is turned to -2, -1, 0 stays, then this one is going to go +1, this one is going to go +2. So let's graph this. -2 and 4. This is -2 and 4, 1, 2, 3, 4. Then I have -1 and 1 positive. I have 0, 0. 1, 1. This is 1 and 1. And you guys can see my, actually the line is the x-axis that I have up here doesn't look on scale. Now it's on scale, okay? So I'm going to go back and erase all of this so I can mark them again. Okay, let's do it again in this color. I had -2 and 4. This is -2, 1, 2, 3, 4. Then I have -1 and 1. Then I have 0, 0, 1, 1. And I have 2 and 4 right there. And I'm going to draw a line, and this is what it's going to give me. Do you see these are the same? That's why I was going to draw this on the different coordinate plane. But this is across y-axis. Okay, it's going to be like the same one, if you can see right there, right there. So that's how the reflection across x-axis and reflection across y-axis goes. Okay, now let's talk about, I have these diagrams. This one is a vertical stretch. Vertically stretching and shrinking. Okay, so what is the rule for vertically shrinking and stretching? If you guys see, this is my original function, y equal f of x. And if you have a coefficient, that c means that's a constant, like a coefficient in front of the function. Probably 2, 3, 4, 5, whatever the numbers are. If that number c is greater than 1, you're going to say if c is greater than 1, then graph is then the graph vertically stretched by multiplying each of its y coordinate, each of its y coordinates. Okay, by c, the c that I'm talking about, a constant, a coefficient. So this is how it's going to go vertical stretch. And you see the blue is my original, and this reddish kind of color is my stretching. It's a vertical stretch because that c, probably whatever number we have, that c is greater than 1. So if I have, for example, 2 f of x, that's why it's vertical stretching. And you can get the vertical stretch by multiplying each y coordinate by c, whatever that number c is. Okay, let's talk about shrinking. If c is less than 1 or greater than 0, like c is between 0 and 1, then the graph vertically shrunk by multiplying each of its coordinates by C. Okay, like I'm doing the same thing for shrinking and stretching, vertical shrink and stretch. I'm multiplying C by each of its y coordinates. Okay, so that's, but the only thing when we look at that, C is the coefficient that I have in front of the function. If this is greater than 1, then it's a stretch. If it's less than 1 or greater than 0, then it's a shrink. So that's what it is. Okay, shrink and stretch. This one is talking about horizontally shrinking and stretching. You see they are like opposite. This one was stretching when C was greater than 1. This one is shrinking when C is greater than 1. But it's horizontal, that one is vertical. Just make sure that you remember this. In this case, if C is greater than 1, then the graph is horizontally shrinking. Then the graph horizontally shrunk by not multiplying this time, by dividing. I don't know why this 3 is there. By dividing each of its x coordinates, by dividing each of its x coordinates by C. Okay, did you see I'm dividing and I'm multiplying up here? Now, if C is, for example, if C is less than 1 and greater than 0, then the graph horizontally stretched by dividing each of its x coordinates by C. Again, if you guys pay attention, the horizontal stretching or horizontal goes like x-axis. That's why we're dividing each x by the C. Vertical is y-axis, so that's why we are multiplying every y coordinate by C. So make sure that you guys remember this, write it down. We will do practice in next video, but right now make sure that you know all of that stuff. Okay, let me give you one equation, and this is a sequence of transformation we are doing, like several transformation. My original function is f of x equal x squared. That's original. Now I have, for example, I have up here a transformation for this x square, and it shouldn't be x squared, it should be gx, because after transformation, this is x squared. Okay, one more time. I want this. Okay, this is just 2. Now the original, the transformation is gonna go something like, why it's not working? Okay, let's forget it. So the transformation is gonna go g of x. Okay, for example, I have 2x minus 1 squared plus 3. If you guys pay attention here, what kind of transformations of all of these? You know that one is, this one is vertical shift upward. It's upward 3 units up, okay? Vertical shift. vertical shift. Now, because this is positive, it means upward. Now, what is this? This means I'm going horizontal shift and it's going towards right. Like I'm going right 1 unit. That's a horizontal shift. What is this 2? 2 is a vertical stretch. That's kind of C, right? The one we just did, that's C, and it's greater than 1, then it's a vertical stretch. So this 2 is vertical stretch because it's C greater than 1. Now the graph, like the original graph, is going to look like this. It's a parabola, so we know the parent function for parabola. It looks like this. That's f of x. Now if I want to draw the transformation up here, and I'm going to do the transformation at the same time. This one is going to go up 3. So 1, 2, 3, and I'm going to go right 1. So I'm going to go right 1, and I'm stretching. So it looked like kind of this. I mean, I'm not drawing in scale, but that's what it is. So this one is the g of x function. Okay, if you guys have any questions, please comment below and I will try my best to answer it, or I can tutor you one-on-one on Zoom. Okay, thank you so much. Have a good day.